Good morning, Year 10. So we're going to continue our topic on ecology with a harder lesson today on pyramids of biomass. Before we get started with that though, we're going to do the starter. I'd like you to have a look at that food chain, answer those 4 questions. The first 3 should be single words, the 4th one's a little bit more difficult. But it's not more difficult, it's a little bit more words. I'm assuming everybody will have no difficulty there at all. We'll get that written down. Pause me for a minute or so. Fine, so the producer is the grass, the 4th trophic level is 1, 2, 3, 4, the python, the secondary consumer is the frog, and how would this look different if it was a food web? Well, it would have multiple different food sources for each animal. Fine, good. Now, let's move on. Today we're going to talk about pyramids of biomass. Now this is a little bit more difficult than what we did before, and there's a bit of maths involved as well. So this does come up quite a lot as part of the GCSE because it's probably the most difficult bit on this little bit of topic. So yeah, worth having a look at in a bit of detail. Now, biomass is the first term we have to understand today. Now biomass is the mass of material in living organisms, not including the water. Now the reason why we don't include the water is because your mass will change dramatically through the day. Okay, so the average person changes by 7 or 8 pounds a day, their mass, based on the amount of liquids in their body. If you remove the liquids, then your mass stays fairly much constant and it depends on what you eat. So if I was to take you and weigh your mass, it would not tell me anything about your biomass. And actually, it wouldn't tell me anything about your feeding relationships at all, because it would change throughout the day. So what I would need to do is take you, remove all the water from you, turn you into a kind of a squishy cube, and then weigh you, and then I would have a biomass. And that biomass would change depending on whether you'd had lots of food or too little food. It would also change depending on what you eat and the efficiency of how you eat it. So ultimately, you got the idea that all the energy and all the biomass is built up from the sun. So the plants are using the sun to make glucose and other chemicals like oils. And that's passed on through food chains and food webs into the animal that eats the plant and into the animal that eats that animal. Right, you're going to need to get these notes down. These are quite important ones. You have to understand what biomass is. So pause me. Excuse me. Right. So, each time you go up a trophic level, the biomass reduces. Why would that be? Have a think about that. Why would that be? Why is it that if I look at the biomass of, say, wheat, there's a huge amount more biomass of wheat than there is biomass of humans eating the wheat. But why? Why can there not be a higher biomass of humans? And the reason for this is this. Every time an organism is part of a food chain, every time a trophic level is added, a lot of the biomass is wasted. So, let's take this horse as an example. This is a very simple 2-stage food chain, grass to horse. But even if the horse ate all of the grass in the field, and that's the first thing to mention is that nothing eats all of the biomass of its prey, so it doesn't. But even if it did, it wouldn't eat all of each bit of grass because it wouldn't eat the roots, it would only eat the leaves. And once it's taken in those leaves, lots of it is wasted. So some of it is used up for movement, that kind of thing, energy. So we burn the biomass to do respiration, to release energy. Some of it is wasted as heat from respiration. So remember, respiration is an exothermic chemical reaction. So you take some of that biomass, you burn it. A lot of that energy is used for movement and whatnot, but a lot of it is also lost as heat. Some of the biomass is lost in the urine or feces, and only what is left is turned into new biomass. which is what then, if there was a lion in the field eating the horses, the lion would have access to. Regardless, the vast majority of the biomass is wasted completely. So you can't have a food chain where the consumer has more biomass than the producer, because it's not possible for a consumer to take in 100% of the biomass from the producer. And even if it did, it would only have the same biomass as the producer. Right, 3 questions here. All organisms in a food chain originally get all their energy from one place. Where is this, etc.? Can you please pause me and do these 3 questions in full sentences? No, not full sentences, just the answers. Fine. So, all organisms get their energy from the sun. Now, this is a classic question in an exam mark scheme. They will show you a food chain looking like, say, that one, and they will then say, where has the energy for this food chain come from? And maybe half of people write grass, because they can see that everything comes from the grass in the food chain. It's very clear that the energy for the grass came from the sun. So the answer is always the sun. And it's something that a lot of people get wrong. If you get it right, you'll get marks that they won't. Fine. What is energy be used for? Terrible. What is energy used for within an organism? It's used for movement and growth. Some of it's lost as heat. Some of it's used for building new tissue. Some of it is wasted as feces and urine. What is biomass? It's the dry mass of an organism. It's the mass of an organism without the water. Now, we can calculate how efficient biomass transfer is by calculating the percentage of biomass which we pass on. So it's a very simple sum you can do here. If you want to know what percentage of the biomass from a prey or from plant is passed on to the next trophic level, you simply do the mass of the new trophic level divided by the mass of the old trophic level, the mass of their prey, times 100. So I've got an example there, 50 kilos of rabbit, that they've eaten 300 kilos of biomass. So we do 50 divided by 300 times 100. 60. So we're going to do some sums on this, which shouldn't hopefully be too difficult. Now, have a look at this. I'd like you to write down the food chain at the top here, and I'd like you to tell me the answers to these questions in full sentences, please. So this is quite important, particularly number 2 here. We haven't written any notes about yet. It's very important that you have these answers written down in full. So full sentence answers to these questions. Pause me. Should take you 3 or 4 minutes. So, we should have seen initially that this number in the middle is strangely laid out. And so we should work out that's 123 kilograms. If you haven't done that, if you've used 123,000, you'll get some very strange results. I've done that deliberately because it's the kind of trick question they throw out there in the exam. So if you haven't got that out of 123 kilograms, then you need to go back and redo your maths and fix that before I give you the answers. Once we've worked that out, then the percentage of the wheat's biomass transferred to the mouse is 123 kilograms divided by 1,000 kilograms times 100, which should give you an answer of 12.3%, is the number I've got there. What happens to the rest of the biomass? Well, that's a very complex question, but broadly, some of it is not eaten, so the mouse hasn't eaten all of the wheat. Some of it is wasted as heat energy from respiration. Some of it is used as movement energy. Some of it is excreted. 4 marks there. Should be getting all 4. If the percentage efficiency of the biomass transfer from the wheat to the kestrel is 4%, how much biomass ends up in the kestrel? I've got a number of 4.92 kilograms. And where does all the biomass come from? It all comes originally from the sun, providing energy to the plants, which then use that energy to create glucose and photosynthesis. Fine. Now, It's all very well having those numbers like that, but actually that's a quite clunky and difficult way to view it. And if you have large food chains, or if you don't want to be typing out numbers all the time, it's quite helpful to have that laid out in a diagrammatic form. It's the difference between having a table and having a graph. With a table, you have to read it and think about it and work it out. With a graph, you can look at it, oh, that's higher than that, easy. With this, we don't need to do a graph, we do something called a pyramid of biomass, or a pyramid of numbers. Now, pyramid of numbers is the first one we're going to look at, and that is the least useful of the two. Still fairly useful. This pyramid of numbers literally just tells you how many of each organism there are in an area. So if I send you out into the copse and ask you to count how many trees there are, how many caterpillars there are, and how many birds that eat caterpillars there are, you could then produce me a pyramid of numbers. Now, a standard pyramid of numbers will be a pyramid like this bottom one here, the yellow one, where there's a lot of whatever plant it is, then there's less, but quite a few, herbivores, and there's even less predators, carnivores. And that makes sense. It makes sense for there to be less things eating whatever there are at the bottom. So it makes sense to be more grass than there are snails. Sometimes that's not true. If you think about something like a tree could hold 10,000 caterpillars, it's a big one, and the caterpillars could feed 100 blue tits. And so in that case, you end up with something like the red one up here. And that just tells me there's only a few trees, but there's lots of caterpillars, and eating those caterpillars, there's quite a few birds. And then down here, this only really happens with parasites, but the parasites eat the aphids. Slowly, but they do it. And so we've got one rosebush, or however many, but a few rose bushes, with lots of aphids on them, and each of those aphids will have lots of parasites. So a pyramid of numbers can go any which way. But if you're looking at a pyramid of numbers, you just need to be able to tell me how many there are of each thing. Now generally, if you were drawing this as a little graph, and they could ask you to draw one, you would have a little naught in the middle, and stretching it in both directions would be, let's say there's 500 grasses, would be 0 to 500. It'll just tell you how many there are. Now, pyramids of biomass are slightly different. Pyramids of biomass are always pyramids. Remember, we said there is always less biomass of the high trophic level than the low trophic level. Always. So if we have a look at a pyramid of numbers for our parasites, aphids, rosebush, it's very, very much lopsided. Because there's not many rosebushes, there's quite a few aphids, and there's a lot of parasites per aphid. If we look at the pyramid of biomass just shows you how much biomass there is of each organism. So let's say there's only one rosebush, but the rosebush weighs 10 kilograms biomass. I don't know. There can't physically be 11 kilograms of aphids living on a 10 kilogram rosebush. So there's always going to be less aphids. And with parasites, whilst there will be a lot of them per aphid, they're not weighing very much in terms of biomass, and so that there's a lower biomass. Because at each trophic level, we lose some of the biomass, like we said, to heat, movement energy, excretion, and all of that stuff. And so, again, this is what you should be seeing. If you are asked to draw a pyramid of biomass and it doesn't turn out to be a pyramid, you've done something wrong somewhere, and that's important. Pyramids of biomass are always pyramids. Fine. Now, I'm going to ask you to construct your own pyramid of biomass. Now, this is easier done in school, in all honesty. I would give you some graph paper and you would do it more accurately. The way I want you to do it in your books today is I would like you to create a pyramid of biomass, and I'd like you to make it to scale. So basically, let's say you decided that 1,000 grams, 1 kilogram, is 1 centimetre. then if the next bar is 3 kilograms, it should be 3 centimeters. And it should end up looking like this pyramid here. And the way you do this is you also need to add on a scale. So you need somewhere near the pyramid of biomass for it to say 1 centimeter width equals 1 kilogram, whatever your scale is. If it's on graph paper, you need to say, well, one large box is 1 kilogram, whatever it might be. And in an exam, they'll give you graph paper for you to draw this on, so you can do exact widths. In your books, I expect you to use your rulers to make it clear. Anyhow, you can get on with this. You're going to use, as I said, you're just going to draw it in with a ruler. You're not going to do step 1 and 2 here. And then you're going to do A and B down the bottom. Okay. Okay, so let's have a look at the answers here. Now, what you should have got is something with a 1 centimeter bar at the top. It doesn't have to be 1 centimeter, it could be 2. You then need the second bar to be 5 times as wide. You need the third bar to be 12 times as wide as the top bar. Now that bit is very hard for me to mark from here. The bit down here we can definitely do though. Okay, so you should have done, what percentage of the biomass of the grass is passed on to the sheep? We should have done 5,000 over 12,000 times 100. Okay, 50 over 12 should be 41.67% is the number I got. And then what percent of the sheep is passed on to the sheep ticks? This is easier, that will be 20%. So, hopefully that wasn't too difficult. Let's do one more, but we're not going to draw this one. No, we're not going to draw that one. Don't do question 1, you've already drawn one. Can you do questions 2 and 3? And again, just pause me. Fine. So, percentage efficiency at each energy transfer. So it's asking you to do exactly the same thing. So between the slug and the robin, you don't even have to do any real math there. It's 23%. That's nice and easy. Between the slug and the letters, you'll probably have to do some calculations here. You do 100 over 1250 times 100. And I got a number of 8% for that one. How much biomass does each slug contain is more difficult. Now, no, it's not more difficult. It just takes a little bit of thought. They'll quite commonly do this. They'll give you a pyramid of numbers and a pyramid of biomass and ask you to work out how much each animal weighs in biomass. So we do 100 slugs, 100 kilograms. Each biomass of each slug is 1 kilogram. They're 1 kilogram slugs. Bearing in mind you're about 80% water, well, that's about a 5 kilogram slug, isn't it? So it's a big slug, is what I'm saying. Fine. So that's nice and straightforward. Now, I'm going to do an exam question on this. Now, I've noted recently that some people are just not doing the exam questions at the end of these lessons. So if you're in my class, you absolutely 100% do need to do these exam questions. And I don't get them for no reason. It's because these are the exact questions you'll see on your next tests, on your mocks, and on your final exams. So please don't skip them. And also, there's some people who are conveniently getting exactly the same answer as I say, word for word. If you are just copying down my answer, you may as well just not do it. It is very obvious. So please just complete the questions. There's 3 marks here, and then another 4 marks there. No, 6 marks there. So, 3 marks here to start with. Have a go at this. Fine. So, what's the source of energy for the food chain? Well, again, this is the classic question people get wrong. A lot of people will write wheat, grains, if they hadn't done this lesson recently. Sun. The sun is the source of energy. Complete the table by calculating the total biomass of red kites and of field mice. Well, we do 2 times 1 is 2. And then we do 200 times 0.04, which is 8, I believe, off the top of my head. It's mental math, so if I've got that wrong, we'll see in the marks. Give me just a second. And then there's another 7 marks here. And you can see, here's another way they could get you to draw a pyramid of biomass. I'm actually not going to get you to do that. I'm not going to get you to do that, because I think you've already drawn out enough, as long as you can see how you would go about drawing it. I wanted more to show you the kind of question you'll see. So just do parts C and D, please. Fine. So, C. Total biomass of the red kites is less than total male biomass of the field mice. Give 2 reasons why. They're basically saying what happens to the biomass here. The biomass is disappearing, so what's happening? And the answers are, you could say, some of it's used in respiration as heat, some of it is used up as movement energy, some of it is excreted, some of it isn't eaten, any of that. Need 2. The scientists could not find the exact number of organisms in the field. Suggest 2 reasons why. Well, the mark scheme says you can't find all the wheat grains, too many to count. The field mice might be hiding, and red kites come and go all the time. Fine. Now, that's the end of that. And I hope you've not found that too difficult. You're going to be asked to draw a pyramid of biomass as the starter for next lesson. You do get asked to do this quite a lot for the exams, so this is something you absolutely need to be confident with. If you're not confident, have a go at this one. The numbers are here. Okay, so you can pause that there. And there's the way you would go about drawing it. But I don't think many people will have had too much difficulty there. Fine. I hope you have a very good day, Year 10. Looking forward to seeing you back in school in the next few weeks, hopefully.